These are your 3-1C system of equation notes. We're going to learn a new method of solving a system of equations, which is solving using elimination. And in that process, we get one of the variables to eliminate. So when you use elimination to solve a system of equations, it's important to have the equations written in standard form. And you have them written right underneath each other in standard form. So you'll have a column of x's, a column of y's, and then a column of c values. And what that does is it allows us to add or subtract the complete equations from each other. And when you add or subtract the equations using elimination, one of the variables will disappear. It'll turn into 0. So this is kind of nice if you look at number 1. Number 1 would be a nightmare to graph, to put in y equals mx plus b. It would also be a nightmare to use substitution. To isolate one of those variables would get very messy. You'd have a really big fraction to plug in, and you'd probably get lost along the way. So a simpler method is to line up our x's, our y's, and our c's vertically. And then if you notice, if we were to add these two together, I add these two equations together, a 4x and a positive 2x make a positive 6x. A negative 3y and a positive 3y cancel, and they become 0y, and they go away. And that's the whole elimination. And then we have to add the numbers as well. So 11 plus 13 is 24. And now we can just solve for x. So you divide by 6. X is equal to 4. We're not done. We still need to solve for y. You remember, we're still trying to figure out where these two lines cross on a graph. So now we just use substitution. So after you do the adding and subtracting, you find one variable, we resort back to substitution. You can plug it into either one of these two equations. I'm just going to go ahead and plug it into the first equation. So 4 times 4 minus 3y equals 11. 16 minus 3y equals 11. I'm going to subtract 16 from both sides. Negative 3y is equal to negative 5. Divide by negative 3. And when you divide a negative 5 by a negative 3, it ends up being a positive 5/3. So that would be a nightmare if you were graphing as well, because to locate 5/3 on a graph is pretty tricky. So my solution, where these two lines would cross, is at the ordered pair 4 and 5/3. I could have plugged it into the other equation as well, but now you can see where the elimination name of this process occurs, because one of the variables disappears. Let's try another one. So in this example, we're not lined up the correct way. So the very first thing I'm going to do is I'm going to make my x values first, then my y values, and I'm going to set it equal to the number. So in the first example, the first equation, that means I need to subtract 3y from both sides. So I end up with a 5x minus 3y equals 7. And in the second equation, it requires that I add 5x to both sides. And so when I write that down, I'm going to put it underneath this one. 5x plus 2y equals 9. Now this time, if I were to add these two equations together, a 5x and a 5x will not cancel. It'll actually give me a 10x. And the 3 and the 2 won't cancel. So in order to get these two equations for my variable to cancel, I have to subtract these two equations. And so when I subtract these two equations, I have a 5x minus a 5x. They cancel. Now you have to be careful when you subtract, because you're subtracting everything, and sometimes we get lost in the sign. So I strongly suggest using a calculator here. Negative 3 minus 2 ends up being a negative 5y. A lot of people want to put negative 1 or a positive 1. If you look at that subtraction off to the side, negative 3 minus a positive 2, you would change the sign and add, and you get negative 5y. So we always have a hard time subtracting positive and negatives when they're vertically aligned. So I suggest using your calculator, slowing down there. When we subtract the 7 minus the 9, again, maybe write them horizontally, use your calculator. 7 take away 9 is going to leave me with negative 2. And so when I divide by negative 5, divide by negative 5, y is equal to 2/5. So we haven't had a whole lot of fractions, but it's still the same as any other number. You're going to plug it back in, and you just got to use the fraction. So use your calculator if you need to. So I'm going to plug it into the first equation. 5x minus 3 times 2/5 is equal to 7. 2/5 is a nice decimal, so if you wanted to write it as a decimal, that's fine too. I'm just going to continue with fraction math. 5x. When you multiply a whole number times a fraction, you put the whole number over 1. You multiply the numerators, which would be 3 times 2 is -6. And then the denominators, 1 times 5 is 5. And then we solve, so I need to add 6/5 to the other side. You can use a calculator. If you take 7 and you add 6/5 to it, I don't have a calculator available, so I'm just going to change 7 into 35/5. It's the same thing as 7, just in terms of fifths. You have 35/5 plus 6/5 equals 41/5. I'm going to divide by 5. And if you divide by 5 over here, it ends up being, when you divide fractions, you multiply by the reciprocal. Again, all of this can be done on a calculator without any thought process. So I get this ugly 41/25, or if you did decimals, you'd have the equivalent to whatever 41/5 is as a decimal. So my solution, remember to make sure you put them in the right order. We found y first, so my x coordinate is 41/25, and my y coordinate is 2/5. And that's where on the graph these two lines would cross. So again, that would be awful to locate 41/25. Now sometimes, actually I'm going to go back real quick. If you notice, the only time that you're going to add or subtract equations and the variable is going to disappear is if you have the same coefficient. So the only reason I could use elimination here was because I had a 5 and a 5, which would, when we subtract, make 0. Or on the previous screen, when we added a -3 and a +3 together, they'll cancel and make 0. So the only time you can use elimination is when you have those coefficients that match. So if you look at this next example, the 2 and the 3x won't cancel, and the 4 and the -6 won't cancel as of right now. But I still want to use elimination. So this is where we do something first to the equations. We multiply the equations so that they do equal. We manipulate the equations so that they'll work. So you line up to eliminate. You're going to multiply the entire equation or equations by a constant to allow for elimination. So sometimes you just have to multiply one equation by a number. Sometimes you have to multiply the equations by different numbers. Once you do that, everything else will be the same. So the very first thing you have to decide here is I can make the x's go away or I can make the y's go away. I like to add these equations. I think it's a little bit easier. So what I'm going to do here is I notice that one of the y values is positive and one is negative already. So if I can keep that, I'd like to make the y's disappear. So I think of a number that both 4 and 6 go into, and that's 12. So 4 and 6 both go into 12 nicely. So I'm going to multiply the 4 equation by 3. So that means I'm multiplying the entire equation by 3, the whole thing, both sides. So I might just put another 3 over here. Whatever you do to one side, you have to do to the other. And on the bottom, to make 6 turn into 12, I need to multiply by 2. So I'm going to multiply both sides by 2. And so what that becomes is everything in the equation on the top is going to be 3 times larger. 6x plus 12y equals 54. And on the bottom, everything's going to be twice as big. 6x minus 12y equals 6. Now when I add these together, I know I see this, the x's are the same and my y's are the same, opposite. So by adding, my y's will go away, but my x's will become 12x, and 12x is equal to 60. and my y's go away. Divide by 12, divide by 12, x is equal to 5. So now that I have my x value, I can plug it into any one of these 4 equations. I'm just going to come over to this bottom equation. There's room right here to solve. So I'm going to plug it into that bottom equation. So 3 times 5 minus 6 times y equals 3. That's 15 minus 6y equals 3. I need to solve for y, so I'm going to subtract 15 from both sides. Negative 6y is equal to negative 12. Divide by negative 6, and y is equal to 2. So when it's all said and done, my solution here is 5, 2. You have some choices when you use multiplication. I could have eliminated the x values by subtracting these 2 equations. So it just depends on what variable you want to disappear. You can also multiply by a negative number to make them opposite signs. I'm going to strongly recommend you always multiply through so that one's positive and one's negative so you can add. You'll have more success when you add using elimination. So, your lesson summary and your practice problem. Good luck.